In today's lesson, we're going to focus on common covalent substances that we see in sort of everyday life. So we looked at, in the previous lesson, all these different types of bonding, and we've seen different examples of those like metallic, ionic substances. So now we're going to look at common examples of covalent substances in our environment. Common covalent molecular elements. Many of the elements that are present in the Earth's atmosphere exist as covalent molecular substances. So nitrogen, oxygen, fluorine, chlorine, they all exist as molecules in the atmosphere, but that is their elemental state. That is the state that we would find them in their element form. Now typically, these are non-metals, obviously, because they're gases, fall into this category. So some examples include O2, N2, or H2. I didn't mention H2 yet, but H2 is one of them as well. These are all elemental forms of these elements, but they exist as molecules. The formation of these diatomic gases is for each atom to achieve stability. So the reason why we have N2, O2, H2, and all of these other ones is because by bonding together in a covalent molecule, we get stability for both atoms. So that's why we try to force this issue in nature. These diatomic gases are essential for our survival. We need these diatomic gases or we won't survive. So obviously the first one we'll talk about is oxygen. So oxygen is vitally important, and it exists as a covalent molecular substance. Obviously, we can understand the importance of oxygen. We need to breathe it in to get energy, and if we stop breathing, we die. That's just how it works. Diatomic oxygen exists as two oxygen atoms bonded together covalently. Now, between the oxygen atoms, there are two bonds, which we call a double bond, in which 4 electrons are shared amongst the atoms. Okay? So what that looks like is, here's one oxygen, and it's got 6 electrons in its outer shell, and it's found its partner, which has also 6 electrons in its outer shell. And what it'll do to get 8 is it'll actually share, each atom will share 2 with the other atom, giving you 8 electrons in each shell. So if I was to erase this one, you can see there's 1, 2, 3, 4, 5, 6, 7, 8. And if I obviously do the same on the other side, then you would also count 8. And how we represent that in a more compact way is we write it like this. So with 2 lines rather than all these dots. We call that a double bond because obviously there are 2 bonds. But a double bond means that there are 4 electrons being shared between the atoms. Okay? So just be aware of that. So what about covalent network elements? We saw a lot of covalent molecular substances, but what about a covalent network element? So elements that exist as network substances are likely to be semi-metal elements. So elements that are semi-metals. So you could put things in like silicon, germanium, or carbon. Carbon is not necessarily a semi-metal, but it does act like this as well. So that's okay. So often covalent network substances are found, covalent network compounds are found rather than the elements, the covalent network elements. So we more likely find covalent network compounds compared to covalent network elements. So an example of this would include SiO2, so silicon dioxide. Silicon dioxide is sand or quartz, so we see that all the time. That's just an example of a covalent network compound. So one example of a covalent network element would be diamond. Diamond is a covalent network substance formed from purely carbon. So here is a nice example of a diamond. Each carbon atom in the structure is bonded to the 4 adjacent carbon atoms around it. Each carbon atom has 4 sitting around it. It's bonded to each of those 4. Each of those 4 is bonded to another 4, etc., and add on to infinitum. So that's how it's bonded together in a big network substance. This creates an incredibly hard substance, and it happens to be the hardest substance known to man. That's diamond for you. And diamond can only be formed through the intense pressures and temperatures deep within the Earth. Within the Earth, there's extreme pressure and very high temperatures. In only these cases can we form diamond. We can't form diamond artificially. It only happens naturally. Though there is some work being done where we have formed some artificial diamonds, but they're not as good quality as the ones that we dig out of the Earth. Okay? So that concludes today's lesson on common covalent substances. We looked at common covalent molecular substances and common covalent network structures, and we looked at an example of each. So hopefully you've learned something about these chemicals, and hopefully you'll be able to answer some of the questions that are coming up.